let's discuss last topic of this chapter, which is trigonometric identities. Identities, you know the algebraic identities, which is a minus b whole square, a plus b whole square. It means that it is valid for all numbers. For trigonometry, we are going to learn trigonometric identities. What are they? Identity means what? It is going to valid for all numbers, but when we say trigonometric identity, that is going to valid for all values of angle. There are three identities, important one, that we are going to learn this year. Let's start. First is relation between sine and cos, then it is sec and tan, then cosec and cot. Let's start with sine and cos. So identity is sine square theta plus cos square theta is equal to 1. Simple. Now what things we need to keep in mind? First of all, there are two trigonometric ratios, which is sine and cos, right? Then it's being squared, okay, sine square, cos square. Then most important thing, value of angle should be same. If it is theta here, then cos should also have theta. If there is a over here, cos should also have a. And if you add them, you are going to get what? 1. Now you must be thinking, how is it possible? So what we are going to do, we are going to take value of one angle and we are going to verify LHS and RHS. If you want to verify with the help of right angle triangle, that also you can do. You can use the formula for sine, which is opposite over hypotenuse, and here which is adjacent over hypotenuse, and you can verify in that way as well. With the help of right triangle, you can take a triangle as ABC, XYZ, whatever works with you. I'm going to just verify with the specific angles. Let's start. So I'm going to take theta is equal to 45 degree and I'm going to verify LHS and RHS. So let's start with the LHS. LHS, sine square theta. So I need to get the value of sine 45, right? So here I will be writing sine square 45 degree plus cos square 45 degree. Simple. Now I need to have two values of which is sine 45 and cos 45, right? Take help of table, that is 1 by root 2 then whole square plus 1 by root 2 here as well. Because at 45 degree angle, we are going to get same value of sine and cos if you observe in table. Same for tan and cot, same for sec and cosec. Okay, so let's start. Here square of 1 is 1, square of root 2 will be 2, plus here 1 and here square of root 2 will be 2. So if you add, you are going to get as 1 plus 1, 2 by 2 and is equal to 1. That is my RHS. You can see. You can verify this angle 30 degree as well, 0 degree as well, 90 degree as well, whichever values we know, right? So this is our first identity, sine square theta plus cos square theta is equal to 1. Remember, it is square. Second thing, you should be having same angles. You cannot take different angles and say that answer will be 1. That will be incorrect. Let's discuss the next one. Relation between tan and sec. Identity is sec square theta is equal to 1 plus tan square theta. Here it is something different. Sec square theta is equal to 1 plus tan square theta. Here we had only 1 on the RHS. Here we have 1 plus tan square theta and LHS only sec square theta. Then here also there are two trigonometric ratios, which is sec theta and tan theta. Then observe that it is square, okay, same as previous one, and value of angle theta here and here as well. So again condition same angle, then only I can apply the identity. Let's verify it. Here also I am going to verify for the value of 45 degree only. So let's start with LHS. LHS is equal to sec square 45 degree. Why 45 degree? Because I am going to verify for the angle 45 degree. So sec square 45. Now value of sec 45 is what? root 2. You can take help of table and you need to do square. So here it will be 2. Done? Now value of LHS is 2. Let's verify for the RHS. Let's find what value are we going to get for the RHS. So it is 1 plus tan square 45 degree. Here 1 plus tan square 45 degree. Now do we know the value of tan 45 degree? Yes, we know it is 1 and I need to do the square of it. So 1 plus 1 is equal to 2. So can I write LHS is equal to RHS? LHS is equal to RHS. Done? Simple, verified. So relation is sec square theta is equal to 1 plus tan square theta. So this is our second identity. Let's discuss the third one. So third identity is, here we had relation between sec and tan. Now we are going to have relation between cos sec and cot. Identity is cos sec square theta is equal to 1 plus cot square theta. You must be thinking it is similar to the previous one, but trigonometric ratio is different. Yes, it is. Now let's observe. First of all, we have two trigonometric ratio, which is cos sec and cot. Second, it's being squared on both. Yes, trigonometric ratio, not whole term or expression. Then one more thing, angles are equal, theta here and theta there as well. Simple. So again, let's verify for theta is equal to 45 degree. Theta is equal to 45 degree. Let's start with LHS. LHS is equal to cos sec square 45 degree. Observe, we have taken value of theta as 45. Now cos sec 45 and sec 45 value will be same. So here root 2 whole square. So it is 2. Now let's verify for the RHS. RHS is 1 plus cot square theta. So RHS is equal to 1 plus cot square theta. Instead of theta, I am going to write 45 degrees. So 1 plus cot square 45 degree. So here it is 1 plus cot 45 and tan 45. Value will be same, which is 1 square. So 1 plus 1 square will give you 2 only. So LHS is equal to RHS. Simple, it's verified in all three cases. Now how to use this identity is very important. How we are going to use it? Maybe we are going to use in the normal form like this one, sin square theta plus cos square theta is equal to 1, or sec square theta is equal to 1 plus tan square theta, or we need to manipulate it. How do we manipulate? Observe over here that suppose if I want to make sin square theta as subject and I shift cos square theta over here. So how can I get the sin square theta value? Sin square theta is equal to 1 minus cos square theta. Right? Simple. Both relation are same. I have just shifted cos square theta there. Suppose if I shift sin square theta there, then what will be the subject? Cos square theta, which is cos square theta is equal to 1 minus sin square theta. This is indirect relation. We are going to use this as well when we solve the sum. You'll come to know how to solve as well. So this is how we manipulate. Let's talk about this one. If we have this kind of situation, then what we need to do? Here you can make tan square as a subject and shift 1 over there. So it will be sec square theta minus 1 is equal to tan square theta. Done? This is a 1. Or if I shift tan square only, so it will be what? Sec square theta minus tan square theta is equal to 1. This is a one more relation I can use. Very important one. Indirectly we can use it. Same identity. It's not being changed if I shift the terms. Right? Let's discuss variations for this one. Again same, it will be similar to this. I shift 1, I shift cot square theta. So it will be cosec square theta. First I shift 1, so it will become minus 1 is equal to what? Cot square theta. Then if I shift cot square theta, that's what? Cosec square theta minus, here it will be cot square theta is equal to 1. Simple. So these are the three very important identities that we are going to use. Here you can do square root as well. If you want to do it cos square theta, remove the square, so it will be square root. Same applies here as well, right? So these are the three identities for trigonometry we are going to learn this year, and let's do few questions based on these identities and the concept we learned so far.